So let's just hop right in. A point is a location. It has no size or shape. We always use a capital letter to name a point in geometry, so this would be point A. It's pretty much just so we don't get it confused with a variable. All this stuff is sort of theoretical. I mean, this is really what you need to know. A line is made up of 2 points. Any 2 points from a line you can use. A line has no thickness or width, right? It's like one-dimensional. Here's an example of a line, XY. We use arrows on either end of the segment to show that it's continuing in either direction infinitely. You can also use a lowercase cursive letter to name a line. So you could say line N. It's a poor cursive N, but you get the idea. You'll see it listed both ways. Collinear points are points that lie on the same line. Non-collinear points are non-collinear, so they don't lie on the same line. If we're thinking about collinear points, point X and point Y are collinear, right? Any plane is a flat surface made up of points. You need 3 points, at least 3 points to make up a plane. This is how you name a plane. You could do plane uppercase letter, or you could just use the 3 points. So I could just call this KJL. You could also do KLJ. You could also do JKL. You get the idea. Like you can name it in any order as long as you have 3 points. Because if you have 2 points, it's just a line, right? If you have 3 points, it's a plane, like it's a flat surface. Think of like a piece of paper. Let's talk about intersecting lines in planes. This is fairly obvious. If you have 2 lines that intersect, they only intersect at 1 point. I'm actually going to change this A to a 1, just so I'm really emphasizing that it's just a single point. If you have 2 planes intersecting, and I think it's best to sort of look at the picture here, it's like 2 pieces of paper intersecting. They're going to intersect not just at a point, they're going to intersect at a line. Do you kind of see that? So it's not just that they intersect at 1 point, right? It's like 2 pieces of paper coming into each other, colliding. So they form a line. Okay, so let's do an example. I'm gonna skip example 1. I think it's a little bit juvenile. I'm gonna do example 2. Okay. So the directions say, use the diagram to the right to name the following a line containing point F. There are many answers to this. There are many lines that contain point F. Oh, I'm sorry. There are not many lines. There is 1 line that contains point F, but there are many ways to name the line. I'm just going to use the lowercase letter method because I don't think many students are familiar with that before they get to geometry. I'm going to call this line and then cursive J. But again, you could also call it DF. You could also call it EF, because remember, a line continues in either direction forever, so it doesn't matter what 2 points you choose. Another name for line K. I'll give you a minute to sort of do that one. I'm going to go with BE. But you could also go with BC. And you could also go with EC. Okay, a plane containing point A. So I want you to name the plane. Preferably, I want you to do it with 3 points. I'm not a big fan of the uppercase cursive. I'll give you a minute. Okay, so you can literally choose any 3 points. I'm just going to say A, E, F. Think of other points on that plane. You could have done D, E, F. You could have done D, A, F. Notice you can't do B. B is not cool, right? Because B is not on the plane. It's above it, right? You need to choose points that are on the plane. Same with C. C is not cool either. An example of 3 non-collinear points. Oh, I don't know. We could say A, B, and D. And the intersection of M and line K, well, that's just a line and a plane. So the line only intersects at 1 point, right? It's one-dimensional, only hits 1 point. This line intersects the plane at point E. Okay, awesome.